Welcome to my channel Fee Concepts CHM. This video is the second part of the series on elasticity, where we are going to see about the Hooke's law. Hooke's law is stated as within the elastic limit, stress is directly proportional to strain. This can be written as stress upon strain, which is equal to a constant, and that we are denoting as E. E is called the modulus of elasticity. Units of the modulus of elasticity is Newton per meter square. So if you consider a rod, if a rod is stretched by equal and opposite forces F each, we can write down the tensile stress as force upon area, that is F upon A. A is the area of cross section. When the rod is stretched, the length of the rod will increase from its original value L. It will now change to L plus delta L. So the change in length is now delta L. So we will write down the tensile strain, which is the change in length upon the original length. So that is delta L upon L. So we will define a quantity called as a Young's modulus, which we will denote as Y. It is given as tensile stress upon tensile strain. So we will substitute this stress and strain in this formula, and you get Y is equal to F upon A, this is the tensile stress, divided by tensile strain, which is delta L upon L. This can be written or rearranged as FL upon A into delta L. This is one type of moduli of elasticity, that is Young's modulus. Now this we will see, that is the modulus of rigidity. It is the ratio of shearing stress over the shearing strain. So we will consider this cube, which is subjected to a shearing strain by applying a tangential force to the upper surface EFGH. So by the application of this tangential force, the face EFGH will slide to a new position, that is E dash, F dash, G dash, H dash. Here the bottom surface, that is A, B, C, D, it is assumed to be kept fixed. Only the upper surface will move. You can see that now this new surface, that is A, D, E dash, F dash, it is tilted by an angle theta. Same thing we can say for this surface B, C, H dash, G dash, it is also tilted by an angle theta. So we will write down the shearing strain, that is tan theta. Tan theta, it is this opposite side, which that length, that is denoted by L. This is L divided by the adjacent side, this length is capital L. The shearing strain is considered to be small. The shearing is considered to be small, hence we can write down tan theta as theta. So theta is equal to L upon capital L. So we will write down the modulus of rigidity, which we denote as eta. It is the shearing stress, which is F upon A, divided by the shearing strain that we have got as theta. That theta we can substitute here, and rearranging it, we get FL upon AL. Third is Third type of moduli of elasticity is the bulk modulus. It is the ratio of volume stress over volume strain. So, if you consider P as the volume stress, which is the same as the pressure, and delta V will be the increase in the volume, we can write down the bulk modulus, that will be the volume stress, which we have substituted as P, and divided by the volume strain, which will be the change in volume divided by the original volume. So, change in volume occurring is delta V divided by V. Minus sign makes K positive as the volume actually decreases on the applying of the pressure. There is yet another kind of modulus of elasticity associated with the longitudinal stress and strain. If we consider a rod or a wire having length L and diameter D, that is shown in this diagram. The length is L and diameter is D. Applied force F produces a small elongation dl. So, we are applying this force F, we are stretching the rod, so that will change the length of the wire. Capital L is the original length, now it has changed to L plus dl. So, we will write down the longitudinal extension strain, that is again the change in length upon the original length, so that will be dl upon L. Also, when you stretch the rod, the diameter of the rod will decrease, so there will be a contraction which will denote as dd. So, that is written as lateral strain. It is equal to the change in diameter divided by the original diameter, dd upon d. So, for a cylindrical rod, the length increases and the diameter decreases when the rod is stretched. So, we will define a new quantity, that is Poisson's ratio, which we denote as sigma. It is the ratio of the lateral strain and the longitudinal extension strain. So, that is substituted dd upon d upon dl upon L. It has no units, it is a dimensionless quantity. Thank you for watching this video.